Greetings to everyone. I hope you're all good. Um, it's another day, a happy new month. I even forgot that yesterday was first match, and I'm also in my birthday month. Like birthday is on 20. So, all right. So let's begin with today's business. So in today's session, what we are going to do is we are going to solve tutorial set 4 here, right? So let's do this because it's also plenty. So let me try and then do this as quick as possible. All right. So the first question here is saying that, or is asking that, according to Harry Markowitz, what is the main goal for diversification? Right. So when we say diversification, it's more or less like having different classes of assets in one portfolio. Right. So why will we even have different classes of assets with different risks in one portfolio? The reason is that we want to reduce risk, right? We want to reduce risk. So when we have assets that are negatively correlated, which means that do not actually move in the same direction, then what it means is that our risk of getting a very huge loss will be what? Reduced. So according to Harry Markowitz, the main goal of diversification is to reduce the overall risk of an investment portfolio without sacrificing the expected returns. So we want to reduce the risk, right? But we don't want to sacrifice it by our expected returns. But that's according to Markowitz. All right. So the second point, the second question here is asking us to elaborate on Markowitz's portfolio theory and its assumptions. So according to Markowitz and this guy is a legend. You see, I've been doing some small forest work, right? And I've learned something. So when I heard of this man during class session, I went to read more about him and then what he brought out. And trust me, it it is really helping my trading journey. So according to Markowitz, this man actually revolutionized how we think, changed how we think, right? By focusing on benefits of the diversifications to reduce risk. What he did was that, or the core idea was that portfolio risk and return is not merely the sum of individual assets, but they are determined by how these assets interact with each other. So if you want to know your portfolio return, it shouldn't only be the number of assets you have in there, but it should also, it should be on how they move together. So if you have some assets in a portfolio that move actually in the same direction, then it means that they are positively correlated, which have a higher risk. It's more or less like you as a Kokonsa person having a Kokonsa friend. They be a member asem, because they be a member. But you being a Kokonsa person, getting someone who is quiet, reserved, right? There's some kind of balance, right? There's some kind of diversification in that portfolio. So you wouldn't really have that kind of risky this thing of getting a SEM always. You get it. Even though one day mbenya asem, but any day biya. So one day mbenya asem, we will talk about it in the next tutorial session, right? So some of the key assumptions under his um theory is the expected returns. Expected returns. Right? So the expected returns of a portfolio is the weighted average of the expected returns of the individual asset. So basically what it means is that the ER is equal to the weight of asset X times the return of asset X. all plus the weight of asset Y plus the return on asset Y, right? So that is what it means for the expected returns, right? So investors aim to maximize the expected return for a given level of risk, right? So that is it though. Then another key concept is risk. So according to macros, risk is being measured by standard deviation. Risk is the same as standard deviation. Standard deviation. So what he's saying, the risk of a portfolio is represented by the variability, which is the standard deviation of the portfolio returns. How they how they are far from the mean, right? So that is it for the risk. So we are trying to say, or we are trying to bring out the key concepts in his theory. The third one is the efficient frontier. Efficient frontier. So the efficient frontier is actually a graphical representation of the optimal portfolios that offer the highest expected return for a given level of risk. So if you watch the portfolio theory video or you actually joined class, you saw that there was something like this, where here was the risk and then here was the return. And we had something like A, B, and then C. Then let's say here was let's say here is 5, here is 3, here is let's say 5, let's say here is 5, here is 3, and here is 5. Right? So what the efficient frontier is saying is that we want to find the return that have the we want to find a particular portfolio that have the highest return with a given level of risk. So for example, we have risk here. We have the same return here to be 3, right? But portfolio A has a risk of 3, portfolio B has a risk of 5. Which one will you choose? You choose A, right? Because the risk here is small as compared to the risk here in B, but they all have what? A return of what? 3, right? Let's compare B to C also. So B here, for example, has a risk of 5. C also has the same risk of 5. But here, B is having what? A return of 3, and then C is having what? A return of 5. So clearly, you are going to choose what? C, because C has a higher return with the same risk as compared to B. And when you are comparing A to B also, A has a lower risk with the same returns as compared to B, right? So that's what the efficient frontier tries to tell us. Okay, so let's move on. So the next one in the key concept is the diversification, right? So diversification. So the diversification reduces the portfolio risk by investing in a variety of assets with different risk and return characteristics and correlations. So the lower the risk, the higher the risk reduction, or the lower the risk. So the sorry, say the lower the risk. So the higher the correlation, right? The higher the risk. So when the correlation is low, the risk is also low. So we will we will use some mathematical expressions to uh, prove this very soon in the last question, where we will see that when the correlation is high, the risk is high. And when the correlation is low, the risk is low. The next one is portfolio optimization. optimization, right? So another portfolio optimization. Markowitz proposed that investors should build a portfolio by selecting asset combinations that minimizes risk for a given expected return or maximizes return for a given level of risk. This process is called what? Portfolio optimization. So that's what we introduced on the graph here, where A, B, C, right? And then we say we are going to choose A. We are going to choose A instead of B because they have the same return and then different, B have higher risk. And then when we are comparing B to C, also the same thing. So we are supposed to select asset combination for a given expected return, right? For a given expected return or minimizes return for a given level of risk. So that is it for the portfolio optimization. So let's also look at the assumptions. So we are done with elaborating on the portfolio theory. Let's move to the assumptions. So you Ankasa, the thing is that almost every theory, so if I don't know any theory that doesn't have assumptions, all the theories have assumptions. So before you propound a theory, you will be having an assumption. So one of the assumptions under Macquarie's portfolio theory is that they assume that investors are rational investors, which is actually might not be true. Because when you read something about behavioral finance, you'll see that investors are actually not rational. They are not rational. So under the rational investors are rational and risk averse, meaning they prefer less risk to more risk for a given level of expected return. They aim to maximize return whilst minimizing risk. So that's the first assumption here, that investors are rational. They always want to increase expected return, but want to reduce risk, right? The second point is efficient markets. So this boils back to business finance too, where we did efficient market hypothesis, right? Yeah, efficient market hypothesis. So here, what Markowitz, efficient market. So here, what Markowitz was trying to say, the assumption here is that all investors have access to the same information and markets are efficient, meaning securities are priced fairly, reflecting all available information, right? So that's the second point or second assumption. Let's move on to the third assumption. The third assumption is that returns are normally distributed. Right? So the third assumption is that the returns are normally distributed. So the returns of assets are assumed to follow a normal distribution, meaning they can be fully described by their mean, which is the expected return, and then the standard deviation, which is the risk, right? So meaning that it is easy to determine the expected return and then also the standard deviation when dealing with the Markowitz theory, right? The fourth one here is risk is measured by standard deviation. So we know standard deviation under the Markowitz theory is risk. Is risk. So the risk of an asset or portfolio is measured by the standard deviation of its returns. This focuses on total risk rather than differentiating between systematic and market risk, systematic risk and unsystematic risk. So basically, what we are trying to say here is that the risk of the assets are multiplied by their width, right? And we are trying to focus on the total risk rather than differentiating between the systematic and then unsystematic risk. Remember, the systematic risk affects every distance, right? And then the unsystematic risk as like affect a specific kind of asset. Okay, so let's move on to the next assumption, which is correlation between assets. So correlation between assets. So the relationship between different assets is captured by their correlation. Assets that are negatively correlated are ideal for diversification as they move in opposite directions, which help reduce the overall portfolio risk, right? So me using the Kokonsan as an example where, no, these days it is just someone who likes gisting, and then someone who is reserved and doesn't like talking, right? You have some kind of what negative correlation, and or someone who dances and someone who sings, right? There's some kind of difference there. Yedi bia na obesa na oshu asay. Yedi bia so na beto no mic asay. So you see, that's it. So the next point here is that under the macro history, we assume that there is no taxes or transaction cost. So meaning that you can trade freely without paying any taxes or any transaction costs, right? So you can trade freely without incurring any of these costs. That's what it means here. The last but not the least is a single period investment horizon, right? So investors are assumed to be concerned with maximizing their return over a single period rather than considering multiple periods of return. So basically, they are only interested, like they assume, say, investors are only looking for one period of return, not like multiple periods, right? So we are done with question 2. If you have any further questions, if you didn't understand any concept, you can actually drop a comment, and then yeah, you can actually drop a comment, and then I will explain further. Kindly don't forget to also like this video and also subscribe to the channel if this is your first time here. So we are done with question 1 and 2. So question 3, under what circumstance will portfolio A dominate portfolio B, right? If you can't remember anything here, you draw your frontier, risk, return, right? You bring your A, B, and C. So I use here to be 3, then here to be 5, here to be 3. Right. So under what circumstance will portfolio A dominate portfolio B? So portfolio A, looking at it here, will dominate portfolio B if the risk in portfolio A is lesser than the risk in portfolio B. That's the first point. When the risk in A, the risk of A is less than the risk of B, right? And also when the expected return of portfolio A is greater than the expected return of portfolio B. Do you get it? So portfolio A is going to dominate portfolio B when first the risk of portfolio A is less than the risk of portfolio B. And second, when the expected return of portfolio A is greater than the expected return of portfolio B. This is simple. I'm sure we are going to remember if in case it comes to exams. So we are done with 3. Question 4. Portfolio attractiveness increases with expected return and reduces with risk. However, when returns increases with risk, investors can choose between portfolios based on their expected utility. This expected utility is usually given as U is equal to the expected return minus the scaling factor times the risk aversion or the coefficient of risk aversion, and then times what? The variance or standard deviation squared, right? The question here is that what do the individual terms mean? So question 4A, right? Where the individual term? Remember, U is equal to E R minus 1 over 2 A under deviation squared, right? The individual term means U is equal to utility. Remember, in economics, utility is what? The satisfaction a consumer gets from consuming a commodity. And here is the satisfaction you are getting from the portfolio, right? So U is utility from investing in the portfolio. Sorry, U is utility. ER is the expected return and then 1 over 2 is equal to the scaling factor. And then A is equal to the coefficient of risk aversion. Of risk aversion. And then this is equal to the variance or standard deviation squared. Yeah, okay. So these are the individual terms. U is utility, ER is expected return. The 1 over 2 is the scaling factor. A is the coefficient of risk aversion. And then standard deviation squared is variance. Now, so let's move to B. B is saying that risk neutral investors will have a coefficient of 0. What does it mean? Right? So risk neutral investors will have a coefficient we have a coefficient of 0. What does it mean? So what it means is that they only judge risk prospect solely by the expected rate of return. So their risk is only judged by the return that they are getting. The level of risk is irrelevant to the risk neutral investor, which is no penalty for risk. So we can prove it by putting it here. Here's the formula, right? U is equal to expected returns minus 1 over 2 A standard deviation. Right. Now, A is 0. Right? A is 0. So when A is 0, A is multiplying everything here. So ER minus 0 is equal to what? The utility. So meaning that the utility is equal to E expected return. So we see they only judge their utility by the expected return. So here when we multiply, when we put A to be 0 and we multiply 1 over 2 by 0 times standard deviation, everything is going to be 0 here. Right? So that's the same thing here. So you see that their expected return is what? Equal to their utility when it comes to the risk neutral person, right? So the next person is the risk loving investor will have a coefficient less than 0, meaning that he will be falling in the negatives, right? What does this mean? So what this means is that the risk-loving investors are happy to engage in fair games and gambles. They adjust the expected return upwards to take into account the fun of confronting the prospect risk. So if we get any standard deviation, we will solve a question soon where we will be putting figures in. If we get any standard deviation, and then we now reduce the distance to negative, let's say -2, we will see that this is going to what? Become positive. A is going to become positive in here. So when we here already negative is multiplying this whole equation in here, right? So if A becomes negative and 1 over 2 times that negative times that they should give us a negative in this bracket. Now when the negative multiplies what is in the bracket, you'll get positive. So you see the expected return is going to add or expected returns plus whatever we are going to get here, right? And then you will see that their satisfaction is going to increase. That's why the risk-loving investor um, have a coefficient of less than negative, less than 0. Now let's move to the risk-loving person. Okay, see, that's the risk-loving person, right? Let's go to the risk-averse person. So risk-averse person will have a coefficient greater than 1. What does this mean? So what it means is that putting the same thing here, greater than 1 means the thing is positive, right? So let's say we put 2 here. When we put 2, it's positive. Whatever we are going to get in this bracket is going to be positive, and this negative is going to multiply what is in the bracket, right? And then making it what? Negative. Now, when the expected return subtracts or minuses whatever is in here, you are going to see that the expected return is going to what? Is going to decrease. So they prefer lower risk for the same kind of expected return. Now, let's move to question 5. That is going to clarify what we've said so far in question 4. So question 5 is saying that an investor has a risk aversion coefficient of 5. He wants to choose between 3 different portfolios: portfolio L, portfolio M, and portfolio H. Portfolio L is a low risk portfolio, portfolio M is a medium risk portfolio, and portfolio H is a high risk portfolio. The risk and return of the individual portfolios are given below. So this is portfolio L, this is M, and this is what? Age. So let's solve and then see the portfolio that will give him the highest return. So they are saying that which portfolio should this investor choose? So let's solve. So look at it here. You are going to use this formula for all of them. So U is equal to the expected return minus 1 over 2 A standard deviation squared. Right. So for portfolio M, we start from L. So for portfolio L, what are we seeing here? U is equal to the expected returns that you are seeing in portfolio L is what? 0.07. Put the same thing here. 0.07 minus into brackets 1 over 2, which is the scaling factor, is automatic. Now, the coefficient of risk aversion, which is the A, is what? 5. Do the same thing here. Times 5 times. Now the standard deviation squared. So the standard deviation here is what? 0.05. So it's going to be 0.05 squared. And we are going to get 0.6 0.06 375. You can put the calculator. So 0.07 minus into bracket 1 over 2 times 5 times 0.05 squared. That's the same thing. All right. So this is the utility for portfolio L. Now let's go to the next portfolio. Portfolio M. So for portfolio L, U is equal to the expected return. Let's look at the expected return for portfolio M is 0.09 minus into bracket 1 over 2. The risk aversion is still 5 times standard deviation here is 0.1. So 0.1 squared. So change here 0.1. Okay, 0.09. We are getting okay. 0.1. Sorry. We are getting 0.065. Now let's move to portfolio H. Portfolio H blue is equal to expected return is 0.2 and then the standard deviation is 0.25. So it is 0.13 and then 0.20. 0.13 and 0.20. Eight times 0.2 squared. Times the risk aversion 5 times 0.2 squared getting 0.0. So you see, the investor is going to select the portfolio that gives him or her the highest return. So look at it here, or the highest utility. So here, portfolio L, the utility is what? This, right? The utility is this. And then portfolio M, the utility is this. And then portfolio H, the utility is this. So you can see that portfolio M offers was the highest utility. So that's what the investor is going to choose. So the investor is going to choose portfolio what? M. Investor is going to choose portfolio M because that gives him the highest utility. Right. So that is it for question 5. Question 6 is also similar to question 5. So you can use the understanding you are getting on question 5 to solve question 6. And I'm sure it will actually elaborate and increase your understanding. All right, so let's move to question 7. Question 7. An investor has investments in 5 assets held over different holding periods. He wants to compare the performance of the investment using the returns over the various holding periods. Using the returns over the various holding periods are indicated in the table below. To find the holding period returns on an analyzed basis and what are the best and worst investments respectively based on the analyzed holding period returns. So these are all in different years. So if we want to convert it, we normally go by this formula. So analyze holding period returns. AHR is equal to 1 plus the HPR, the holding period returns, all raised to the power 1 over n minus 1. Right? So that's what we are going to use to do for all of them. So now let's start with asset 1. Asset 1 is having a holding period of 7.5. Then n is the number of years. So 5 years, we are having 5 years here. So 1 plus 7.5 raised to the power 1 over 5 minus 1. And with this, we are going to get So if you want to get it in decimal, we leave it this way. But if you want to get it in percentage, you multiply by 100. And you get 53.42%. Now asset 2. One plus 0.6 all over 1 over 300 over 365, because we have 365 days. That's what we normally use in a year. So you can do it this way. It's 1. Or it can be 1 plus 0.6 over 8 raised to the power 1 over, raised to the power 365 over 300. Because this is a division. So if you want to do multiplication, it will turn to 365 over 100. So normally that's what I use. So I'm going to use into brackets 1 plus 0.6 raised to the power 365 all over 300 minus 1. So if you don't want to leave it there, you multiply by what? 100. Into the 7.15%. But if you really want to do it this way, then what I will advise you to do is to do it this way, right? Find 1 divided by 300 over 365, right? And then put this at the top. Otherwise, some calculators, when you put this one there, you get wrong answer. So you can do this separately and then you go and put it at the top. So now you are going to do it this way. Bracket 1 plus 0.6 raised to the power and put this, because that's what we get so answer. The same thing, right? So the third one, sure you can try them. Let's do it. Let's have a ration fast from that side. Answer 3 is 1 plus 0.15 raised to the power 1 over 4 months. So it's going to be 4 over 12, right? 4 over 12, which can also be or 12 over 4. Instead of doing 1 over 4 over 12, you can also do it 12 over 4, and then you get the same answer, minus 1, right? So remember, it is raised to the power of, don't go and do raised to the power, so minus 1. Then we are going to get 52.08%, which you multiply by 100. Now let's go to asset 4. Asset 4 is going to be 1 plus, into brackets, negative 0.1. Remember, it's negative. Negative 0.1 raised to the power how many years? So 1 over 2.5. So I'll also read this one. I'll also suggest that you subtract everything in the bracket first. So you'll be left with 0.9 raised to the power 1 over 25, 2.5, sorry. Right, and you are going to get negative 4.13%. Then asset 5. Asset 5 is also going to be bracket open 1 plus negative 0.2. So automatically all raised to the power 1 over 6 over 12, right? Or you can do it all raised to the power 12 over 6. It's 1. So it's going to be 0.8 raised to the power 1 over 6 over 12 minus 1. And then we are going to get negative 36%. Right. So now let's go back to the question. The person is asking us, um, find using the various return indicated below. Okay, so find what were the best and worst investment respectively. So the best investment here is the one that have the highest analyzed holding period. So the best investment was what? In assets 2. It has the highest analyzed holding period. Then the worst one is asset 5. It had what? Negative 36%. So that's what you are going to state there. This is easy peasy and straightforward, right? So let's go to this one because it's easy. Let's go to sub guy. Remember, we are going to use sub guy to solve everything up to here. But I don't know why they changed this to be here. Right. So we are going to use sub guy to continue. So I'm sure here is going to be C, and here is going to be G. Yeah, so A, B, C, and then D, because it's a continuation. All right, so Sharp Guy made the following returns on a stock that he has held for 5 years. So first of all, they're asking us find the arithmetic and geometric mean. So arithmetic mean that's question 8. Arithmetic mean is equal to the sum of the returns divided by the number of years. So it is so simple. So the returns are 15, 25, negative 20, 0, and then 25. Capture. So 15, So I should have brought plus -20 there, but as far as negative is there, no, M fam all over 1, 2, 3, 4, 5. So all over 5. We are going to get 0.09, which is equivalent to 9%. Then that's arithmetic mean. The geometric mean, so for the geometric mean, what we are going to do is we are going to add 1 to all the returns. So 1 plus the return times 1 plus the return plus 1 plus the return. So I want to do it straight here, so that it wouldn't really be long. So into brackets, right? 1 plus the first return. The first return is 15%. So it is 0.15, right? So 1 plus it is going to be 1.15. Multiply it by the second one. The second one is 25%, which is equivalent to 0.25. So 1.25 times the next one. The next one is -20. So 1 plus it is going to be 0.8. So times 0.8 plus, oh, sorry, times the next one is 0. So 1 plus 0 is going to give us 1 times the next one, 25. So going to give us 1.25. Now, for the geometric mean, what we are going to do is we are going to raise the power by 1 over the n, which is 5. 5 minus 1. So this is how the geometric mean looks like. So 1 plus all of the returns, you multiply 1 plus the first return, you multiply by 1 plus the second return, you multiply by 1 plus the third return, you multiply by 1 plus the fourth return, you multiply by 1 plus the fifth return. All raised to the power, into brackets, all raised to the power 1 over 5, or 1 over n minus 1. So doing this, we are going to get 0.075, right? Which is equal to 7.5%, right? Now, we calculated for A. Now let's move to B. B is asking us, how much will an investor earn? How much will an investment of 1,000 cedis grow to the end of the 5 years if he earns arithmetic mean? So if he earns arithmetic mean, this is how much he's going to earn. Arithmetic mean. It's going to be 1,000 into brackets 1 plus that arithmetic mean that we had. So 1 plus 0.09 raised to the power 5. And we are going to get 1, 5, 38.62. So the investor is going to earn 1,538 at the end of year 5 if he's what earning on the basis of what arithmetic mean. So come in. So and then for II geometric, when it ends on the geometric mean, then he's going to earn 1,000 into bracket 1 plus 0.075. It is going to give us a raised to the power 5. It is going to give us it's going to give us 1,435.63. So that's it for the geometric. Now, based, so this, you can see this second thing. Based on the arithmetic mean, historic standard deviation, show the range of values between which an investor should expect returns to fall, given a 68.95% and 68, 95% and 99% probability. So since they have returns here, right, we have some another distance. So let's just use this table. So what we are going to do is because normally these questions work together. So I don't know why here they did it like this, but we have probability, then we have the range, then we have the returns as it's A, and then the standard deviation. Standard deviation is what? They give it to us. Okay, they give it to us to be 19.2. Then the mean expected return, they give it to us to be 9. They gave it to us to be 9. And this is a whole different question. This is a whole different question. Why? It's not a continuation. So question 10. If they hadn't given it to us, and we are supposed to continue from this particular one, right? Then we are supposed to continue from the we are going to use the arithmetic mean we calculated, which was 9%. That's what we are going to use. That's where we are going to put the RA. The RA is going to be 9. That's why that's really the probability of 68%. Now, probability of 58%, the range is basically either one standard deviation away either at the left hand side or right hand side. So when you check on the empirical rule, right, where we did normal distributions in quantitative method. So that's the same application we are going to use here. So when we draw the bell shape like this, and the mean is here, right? First move here, either to the left or to the right, is summing up to 68%. Then the second move further on is summing everything up to 95%. Then the third one, summing everything, is increasing to 99 point, is it 99? Yeah, it's 99%. Right, so 68, 95%, and then 99%. So that's how it moves. So 68 is just the first move. Is just the first move here. And then 95 is the second move away. So we see here is the first move here, -1. And here is also what? +1. Or positive standard deviation. Positive standard deviation. Negative standard deviation. So this is 1, 1. And this is what? -2 standard deviation. This is -3 standard deviation. And here 2 standard deviation +2. And here 2 is what? +3. +3 standard deviation like that. So here is going to tell us the range. The same thing, that's the same application you're coming to use here. So at the probability of 68%, we are either return is going to either RA is either going to be plus or -1 standard deviation. That's what I just depicted. So now it's going to cause the return to be -10.9 and also +28.2. So basically what we are doing here is the first side, for example, is just doing 9 minus 19.2. That's why we are getting this 10 points. Oh, it's 10.2, sorry. Right. And then this one here is basically 9 plus 19.2. So what we are doing is for the left-hand side, we subtract. For the right-hand side, we add. For the left-hand side, we subtract. For the right-hand side, we add. So let's do the second side too. The second side too is RA, return, and either move plus or -2 standard deviation away. That's what I just explained. So this means that here is going to be 9 minus into bracket 2 times the standard deviation, 19.2, plus 2 standard deviation away. Left hand side is going to subtract 2 standard deviation away. Right hand side is going to be 9 plus 2, 9 plus 2 times standard deviation. It's so simple. Now, let me put the actual answer. So, actual answer here is going to be negative 29.4, and this one is going to be 47.4. The third one too is saying that it's 99%, so it's going to be RA plus or minus 3 standard deviation. So if this comes in, it's a bonus question, right? Since you've been able to do this first one and second one, you should be able to do this, right? You can pause the video and then do this yourself. It is going to be, first one is going to be 9 minus into brackets 3 times the standard deviation 3 times the 19.2. And then here it is going to be 9 plus 3 times 19.2. Then easy peasy, you are done. So we are going to get negative 48.6 here. And here is going to be positive 66.6. Right. So you can just put them on a calculator. For example, here it's just 9 minus bracket 3 times 9. That's it here. You see. Then the other one is just going to be plus. The other one is going to be 2. They're just going to be so easy and easy and straightforward. So let's move on. So now B is telling us to find the coefficient of variation. The coefficient of variation is basically coefficient of variation is basically equal to standard deviation all over the arithmetic mean or expected return. So coefficient of variation is 19.2. That was the standard deviation all over the arithmetic mean or expected return is 9. We are going to get 2.13. And now they are telling us to do what? And provide an interpretation. So the interpretation here is that for every unit of return, so for every unit of risk, for example, return is going to be more than 200%. So it is more or less like risk and return. Whatever you risk, you are going to get 2.13. When we multiply by 100, you are going to get 213%. So which is actually good. If you are risking, you are getting 213%. It's actually good for your portfolio, right? Okay, so now let's go to the Ogboro, the main killer of the day. So actually, this is a loaded question, but it's easy. It's easy. Sure, so I'm more than 1 hour through. Let me see whether I can use 20 minutes, 15 minutes, or less than that. So assume we own two stocks, assets X and Y. We have invested 30,000 in asset X and then 60,000 in asset Y. The return for asset X is 30%, whilst Y is 20%. The standard deviation, which is the risk, is what? 15% for X and then 10% for Y. The correlation between assets A and B is given as 0.7 or 70%. So now they say we should find the expected return of this portfolio. Remember the macro is when we said we will be finding expected return. What did I see? Remember yourself. Just the weight of X plus the return of X. The weight of X times the return of X plus the weight of Y times the return of Y. So that's what we are coming to do now. So first, let's first find the weight because they've given us the returns already. So question 10. Weight. Oh, why didn't I go on a screen, man? The weight. So what you are going to do is you have to find the total. So now the total is going to be the 30,000 plus the 60,000, which is going to be what? 90,000. If we want to find the weight of X, we take X, the amount we invested in X over the total. So weight of X, that is WX, is equal to, we invested 30,000 in X all over 90,000. And we are going to get 0.33. Now, if we want to find weight of Y, we are going to take the amount invested in Y, 60,000, all over the total. I think it's going to give us 0.67. All right. So now, as I said, expected return is equal to weight of X times return of X plus the bracket weight of Y times return of Y. So now, what did we get for weight of X? We had 0.33. That is screen. Remember now, someone. What was the return of X in the first thing? The return of X is 30%. So let me write return of X is 30%, so 0.3. The return of Y is equal to 20% to 0.2. So return of x 0.3 plus the return of y. The weight of y is 0.67 times the return of y is 0.2. That's why when we were doing it in the sessions that I recorded, I didn't actually talk more about it because figures were in there. So if you actually don't have figures, you wouldn't really understand it. That's why I also wanted to put in figures in there because now I've spent a lot of time already on the session. So with this, we are going to get we are going to get 0.233. It is equivalent to 23.3%. So this is the expected return, right? Now, B, find the weighted standard deviation of this portfolio. So this is where the wet, you see the wet, the wet gets so plenty, right? So the weighted standard deviation of a portfolio is the weight of assets X, right? And the standard deviation of assets X all squared plus the weight of assets Y times the standard deviation of assets Y all squared plus 2 times the weight of X times 2 times the weight of Y times the standard deviation of X times the standard deviation of Y times the correlation coefficient. So let me write it. So this is the formula. Standard deviation squared. The weighted this one with portfolio is equal to weight of X times the standard deviation of X all squared plus the weight of Y times the standard deviation of Y all squared plus 2 times the weight of X times the weight of Y times standard deviation of X times standard deviation of Y times, oh, I don't know, screen will not time in your power times the correlation coefficients where I do it E and so right? So this is it. It looks plenty, but once you try it 2, 3 times per Rebecca, because I just wrote this without looking at anything. maybe you be thinking same it's deviate. Honestly, I wrote this without anything. And it's because I've been practicing, practicing, practicing. So you can also be practicing, practicing, practicing. If then I make practicing, practicing, practicing. And it will work out. So now, remember, we already have the weights. So now let's bring in the standard deviation of x and y and the correlation coefficient. So the standard deviation for asset x is 15%, and then asset y is was 10. So standard deviation and then the e x y is equal to 0.7. That's what they give. That's what they give to us in the for this down here. Ah, now we have the weight of x to be equal to 0.33, and then the weight of y to be equal to 0.67. Right. So that's what we are going to put in here, and then we are good to go. Right. So this dxy correlation coefficient was also given to us as 0.7. That's it. The correlation between asset A and B has been given to us. So now let's roll. So we are just going to fix everything in here. So this is how it is going to look like. It's going to be So the same formula here, that's the same thing I've repeated here with this coefficient that we put in here. With this same thing, I've repeated everything in here, right? So normally I would advise that if you're using a calculator, you put here, and sorry, it's supposed to plus. So if you're putting it on the calculator, the advisable that's what put here in the bracket. Let's do this. In bracket. Right? So I just entered everything. So 0.4. Okay. 5, 8, 2, 3, two, three, five. So remember, here is what variance portfolio. Want to change it to standard deviation, take the root of this. So this will cancel this, right? So this B is going to be 0.1076. It is equivalent to 10.76%. You get it. All right, so that's it for the second one. It's plenty, but with constant practice, you are going to get it. So what will be the standard deviation if this portfolio, if this, what will be the standard deviation of this portfolio if the correlation coefficient between the two assets is now +1. So they've changed it from 0.7 to +1. So what our advice is that whenever you are done, don't press this on the calculator, press this so that you can just go back and then just go and then change your correlation coefficients. That's all. Change it to 1, and then that's all. Get a new set of this. Now you put it to I come to solve it. So now see. So when the standard deviation is now +1, right? It's now +1. So let me just go and then copy this and come and put it here. This back here. This is now what the formula looks like. Now this guy here, everything is going to be the same. Just bring it again here. Bring this guy here. Bring this guy here. Bring this guy here. And bring this guy here. And bring this guy here. And then this guy is going to change to ×1. That's all. And let me change this guy. Only him to 1. Because that's what we're basically saying. Now, it's going to be like this. 0.135. That's a variance. 0.1357255. So right. But we want to get the standard deviation of the portfolio. We have to take the roots and then the roots. So when we take the roots, what are we going to get? We're going to get 11.65, so 0.1165. So equivalent to 11.65%. Let's go to D. What is D also saying? D is saying, okay, so what did we notice? So we can see, let's look at something. What did we notice? Now, when the correlation coefficient was increased to 1, we can see that the standard deviation of the portfolio has changed what 11.6%, which when it was what 0.7, the standard deviation was for 10.6. So you can see, say, when the correlation is higher, the risk becomes higher, or the population standard deviation becomes higher. So we've noticed that and a higher correlation coefficient induces or brings up a higher risk, right? So that's what we've noticed from this first one. So now the D here, D is saying that what will be the standard deviation of this portfolio if the correlation between these two assets is now 0.4. So now here too, we are going to leave everything the same, only the last one that we are going to change. So let me see whether we copy all this. Let's see. Let's bring this guy. Instead of one, instead of one, what we are going to put here is 0.4, because that's what they told us. So now that's why I say don't clean it on the calculator. Don't press A, don't press star on this thing when you are done calculating. Just leave it like that, or press AC. So now we just go back and then go and change this. We are changing the coefficients of variation to what? Only that one to 0.4, whilst every all of them is the same. So we are getting 0.0095992 9245. Then, because we want the standard deviation, find the root. Standard deviation is going to be 0.097. 0.097. 0.09794, which is equivalent to 9.7 9%. Right. So what have we noticed? We've noticed that when the correlation is low or relatively low kakano, like it's medium here, right? We are seeing what standard deviation. We are seeing a standard deviation to what 9.79, which means it has reduced. So when the correlation is low, the risk is also what's low. So that's what I said up there, that we'll be using calculations to support this. So that's it. When correlation is low, uh, risk is also low. Now, if I'm casting the 20 minutes, right? Then I have if what will be the standard deviation if this portfolio if the correlation between these assets is -1. So the same thing now, but here -1. So Let's bring these guys here again. But science and metro say this same thing. I just change it because we once over typing in a better time in so better over tuning in Google better time in now please sign up for this. So now here they are saying that the correlation is -1. We are just going to change again to -1. We are going to get 0.0003. So we want a standard deviation when the standard deviation is big cancel. The risk of B will now be 0.017. Which is equivalent to 1.75%, which is relatively low, right? So what you've noticed here is that when the assets are negatively correlated, the risk of that portfolio is what? 1.7%. And which shows it is what? When risk is low, when the correlation is low, standard deviation is also what? Low. That's what we've noticed. Now let's go to the next one, which is F. At what weight can we construct a risk-free portfolio? So this is also a bit technical. Open your eyes here. So if you want to construct a risk-free portfolio, what you want to do is that you want to construct a portfolio where everything like the standard deviation will be 0, right? So if you want to do that, what we are going to do is what we are going to do is um we are going to find the weight of the standard deviation. So weight of y and then the weight of x. So if you want to find the weight of the standard deviation of y, right? So weight of the standard deviation of y. It is going to be the standard deviation of x all over standard deviation of x plus standard deviation of y. You get it? So if you want to find y, you use x at the top. And if you want to find x, you use y at the top. You get it? So now, the standard deviation, as we know, is what? 0.15 for x. And then now, both of them 0.15 plus the y is 0.1. So we are going to get 0.6 for this. So if you get 0.6 for this, then change that weight of the standard deviation let me just take this out. So reconstructing a rate speed is just use any weight. because maybe some people will get confused. Because I'm writing it in the way that I understand it. Let me use it this way. So now this is also going to be either you are going to use the standard deviation of y all over x plus y, a standard deviation of x plus y, or you are just going to subtract 0.6 from 1. So 1 minus 0 is equal to 0.4. Right. So these are new weights. So if you want to construct a restrict portfolio, we are going to put this new weight in our formula. Remember our formula there already, right? So let me see whether I can bring the formula down here. This is our old formula. This is our old formula. Let me just add the skirmishes. That's the same thing, right? So just that here we found a new weight. So that's the new weight we are going to use, but still maintaining that old standard deviations, right? So now here's how this thing is going to look like. The weight of x now is what? The weight of x now is equal to, the thing is equal to 0.4, the new weight of x, times its old standard deviation, which is 0.15 squared plus the new weight of y, 0.6 times its standard deviation, 0.1 squared plus 2 times the new weight, 0.4 times 0.6 times 0.15 times 0.1 times, because we want to construct a risk-free portfolio, we normally use -1 as a correlation coefficient, right? So say if you want to put it in on a calculator straight, I advise you put these in brackets. So now our portfolio standard deviation is going to be, let's quickly do this. Let me go and then change because so here -1 is already there. Standard deviation of x and standard deviation of y is already in there. So now let's change the weight. Now it is 0.4 and 0.6. It's 0.6. This is 0.4. So you see, getting standard deviation to 0. So that's what we did. Whatever we did here, you're just going to put everything on the calculator. Then you are going to get a risk-free portfolio. The risk-free portfolio is 0, right? So we are seeing here to be 0. Then standard deviation of P will also be what? Also be 0. So this is a risk-free portfolio, right? So it's so simple, easy peasy, right? Hey, did I do Jane? Jane is what will be, oh, I jumped to H. So let me do Jane. Jane is saying what will be the return on this risk-free portfolio? So remember our expected return, right? Our expected return is equal to um normally weight of x times the return on the x asset, and then plus the weight of y times the return on y. And this is going to be equal to the new one that we just of 0.4 times 0.3, which was the return, plus 0.6 times 0.1, was the return, then not 0.2. Then we are going to get something around 24%. So June, the expected return is 24%. So we are just going to maintain the same returns that was there. So if just imagine you are constructing a risk-free portfolio that will not have any risk, and then you are getting returns of 24%. Hey, we are using the same returns here. Portfolio that will not have any risk, no loss. Wow, so see, we are using these returns here. All right, so now let's go to the so show the variance and the standard deviation of this risk-free portfolio. So that is what we've done here. The variance and the distance, the risk-free portfolio is what we've done here. Is what we've done here. So this was rather H. All right, so now let's look at the last one, then we close. So the last one is saying distinguish between efficient portfolio and efficient frontier. So basically, the only difference between them is that the efficient frontier, as I illustrated earlier, is the graph that shows the potential or efficient kind of portfolios in there. So uh, see, I do the graph and do the graph like this, and then risk, and then return. And then I said A, and then B, and then C. Right. So A, B, C on this graph is the kind of the portfolios that we think they are efficient. So the ones that you think is efficient, for example, between A and B, he said the same kind of return. A is having a smaller risk, so A is efficient here, right? And then the same kind of what return also here, the same kind of risk. C is efficient here because it has what a higher return, right? So that's what you can actually use to do one of the difference. Or you can say the efficient portfolio is one that provides the highest expected level of return for a given level of risk, or the lowest risk for a given level of expected return. So it aims to it aims to maximize return for each unit of risk. And that's what I've illustrated here. Whilst the frontier is a graphical representation of all the efficient portfolios available in the market. It, it forms a curve on a risk and return portfolio. So that's what I've just illustrated. So the graph is the frontier, whilst the portfolio that we think are efficient here are the efficient portfolio, right? So you can see that here, the same kind of risk, but between A and B, the same kind of return, but A is having smaller risk, so A is efficient. And also between B and then C, we can see that the same level of risk, but C is having what higher return. So that is it. Right, that is it. So this sums up, or this is where we end today's session. I hope you enjoyed it. Kindly leave me a like and also a comment if you find this helpful. If you have any further questions, you can drop it in the comment section, and then I'll come and then explain further. Thank you very much for your time. See you some other time. Bye.